Okay, gang, so I'm gonna make a little video to explain how to graph some of these quadratic functions that we did in class, just in case you want to review or if you were absent, that kind of thing. So basically everything from this unit that we've done thus far. Alright, so some of the key things that you want to remember. Of course, a quadratic function, it's called quadratic because you have some term, some variable that's squared. So the general form is y equals ax squared plus bx plus c. A can't be 0 because if a was 0, then it wouldn't be quadratic. You can see that term right there. If a was 0, you would no longer have the quadratic term. It'd be linear. It would just be a constant. Now all the quadratic functions form the shape of a parabola, so it's a parabola that either opens upward or it opens downward. It's logical that if it opens upward, it's going to have a lowest point, and that lowest point we call a minimum value. And that's going to be where the vertex is. So the minimum value is actually the y-coordinate of the vertex. If the parabola opens downward, then it's going to have a highest point, which we call a maximum value, and that's going to be the vertex as well, and that's going to be, the maximum is the y-coordinate of the vertex. So just a couple of pieces of information. You can tell when a parabola is going to open upward or downward just based upon the number that's in front of the x squared. So if the a is positive, if a is greater than 0, we say, then it opens upward. And if a is less than 0, then it opens downward. One key feature that we find when we're graphing these is the equation of the axis of symmetry. This is the line that cuts the parabola perfectly in half, and it creates perfect symmetry, we say. So the way we find the equation of the axis of symmetry is we just say x equals negative b over 2a. Just plug in your numbers, and there you have that line that cuts the parabola in half. Just make sure that you always write it as an equation, x equals, and not just a single number. And I think everything on this page I've already talked about with the previous slides. I just want to mention that when you're looking for the vertex, that is going to be the same thing as the axis of symmetry. So that's the x-coordinate of the vertex. And if you want to find the y-coordinate, then you just plug in that x-coordinate and you figure out the y-coordinate that goes with that. Again, maximum is if a is less than 0, that just means the parabola will open downward. And if it has a minimum, that's going to be if a is greater than 0, so the parabola would open upward, like that. Okay, so let's get into an example. So graph the following quadratic function. So first, the AOS, that's just the axis of symmetry. So just abbreviation. So axis of symmetry. It's the equation of the axis of symmetry. Okay, so negative b over 2a. So first identify what your a is. So the a is the number that's in front of the squared term, the coefficient. So a is 1, b is negative 2, and c is negative 4. So let's plug in our numbers. The opposite of b is 2 over 2 times 1. So the equation of the axis of symmetry is just x equals 1, 2 divided by 2. Then if you want to find the y-coordinate, we just plug it in. So we have y equals, and we plug in 1 squared minus 2 times 1 minus 4. So 1 minus 2, that's negative 1, and then minus 4 more. So that gives us a y value of negative 5. So we put the two together, so the coordinates are 1, negative 5 for the vertex. So let's go ahead and go to the graph, see what we have so far. So we have 1, negative 5, so let's plot that. So 1, 1, 2, 3, 4, 5, so there's dot. Oops, back up a sec. Okay, let's try this again. 1, 2, 3, 4, 5. Okay. And the next thing I say to find is the y-intercept. So the y-intercept is going to be, whenever you want to find that, all the points on the y-intercept here, they all have x coordinates of 0, because you're not going left and right at all. So it's going to be 0 something. Now it's pretty easy to find, so if you look back at the slide before, you can tell that if you put zeros in, oh boy, sorry, if you put zeros in for all of the x's here, you can tell that you would get -4. So if you put 0 here, a 0 there, so your answer would be -4. So let's go back to the graph, and it looks like it's going to make me plot my points again. So I got 0, or I'm sorry, the vertex is 1, -5, so let's plot that one. So 1, 1, 2, 3, 4, 5, so there's that point. So this is 1, -5. I found the y-intercept by plugging in a 0 for the x, and that turned out to be 4. I'm sorry, -4. So 0, -4. So I go 1, 2, 3, 4, there's a dot. And remember, the axis of symmetry cuts the parabola perfectly in half. So that means my parabola is going to open up like this. And then what I can do is I can use the symmetry. Good logic is that it's 1 unit over from the middle, and then I just move over 1 more unit that way, and then I can get my other point. Now, of course, if that point is 0, -4, then just straight across, I would just go 1 more unit over from 1, so that point right there is 2, -4, because you can tell it's at the exact same level as the 0, -4, so 2, -4. And that's really it for graphing. You just need to get, 3 solid points, I'm going to say, to get at least the shape. Alright, let's look at another example. So this one, again, be really careful about your A, B, C. So we have A equals -2. B equals, now in this case there's no x term, so the B is 0, and then the C is +8. So we do the same thing every time. We do x equals -b over 2a. So the opposite of b, can't really have the opposite of 0, so just 0 over 2 times -2. Now 0 over any number is going to be 0. Unless you're dividing by 0, then it's undefined. So x equals 0, and then we can plug in 0 into the original equation. So we get 0, all of this becomes 0, so 0, 8. So that's our vertex, 0, 8. Now this time we can't really find the y-intercept because the vertex is the same thing as the y-intercept. So I'm going to go ahead and plot that point. And that'll be, oh, sorry about that. So that will be 0, 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And this parabola, let me write the equation again here. Sorry about that. So 0, 8, 1, 2, 3, 4, 5, 6, 7, 8. And then let me write that equation. So y equals -2x squared plus 8. You'll remember that I said if the a is negative, that it opens downward. So of course this parabola will open downward. Now I need another point, so what I can do is I can just plug in any point really, but I'm just going to plug in a 1. So I'm going to put a 1 in for the x, and when I do, that would be -2 times 1 squared plus 8. So -2 plus 8 will be 6. So that means I have 1, 6 as another point on the parabola. 1, 2, 3, 4, 5, 6. And then remember the equation of the axis of symmetry is x equals 0, so that's just a line, cuts it right down the middle. So I can use symmetry. If this point is 1, 6, then I can just find the other point right on the other side of the parabola, the other side of the line of symmetry. And so that point would have to be, logically, it would have to be -1 and then +6. So there's another point that's on the parabola. So -1, +6. And really that's all there is to it. Is that a max or a min? Well, whenever the parabola opens downward, then that turns out to be a maximum. And you can just logically look at it. It has a highest point, not a lowest point. This parabola would extend, these would extend, and so we wouldn't really have a lowest point. Okay? So now let's get to a little application. I just did that one. Okay, so let's say we have this carnival game, and the little sledgehammer thing where you hit it and then the little weight goes up a tube and it either rings the bell or it doesn't. So let's say we have an equation that describes the height of the weight that goes up the tube, and this equation is given right here. So let me just highlight it. So I made it a little bit bigger. So this is the equation. It describes the height, and the question is it going to ring the bell? And so this is 20 feet high, right here. And so what we need to do is we need to look at this equation and try to figure out, does it ever reach a height of 20 feet? So what we can do is use our skills that we were just doing to find the maximum. Remember, this is a parabola that opens downward because it's -16 as the a. So it does open, it's going to go like this. So we just need to figure out what is that maximum height, and if the maximum height is 20 feet or more, then we know it's going to ring the bell. If the maximum height is not 20 feet, then we know it's not going to ring the bell. So let's identify our A, B, and C. So A equals -16, B equals 32, and C equals 3. So normally we have x equals -b over 2a. This is the same thing, it's just we're going to say that t equals -b over 2a. In this case our x variable is a t variable, and our y coordinate is actually an h for the height. So let's go -b, so the opposite of 32, so -32 over 2 times the a, which is -16. That's -32 over -32, which is a +1. So that means at 1 second, the weight is going to reach its maximum height. So now we need to figure out what is that maximum height. So we just need to plug in a 1 everywhere where there's a t. So -16 times 1 squared plus 32 times 1 plus 3. So -16 plus 32 is 16 plus 3, and that's 19. And that's 19 feet. So does find the maximum height of the weight, it's 19 feet. And then will a prize be won? No. So no prize won, because again, it doesn't reach a height of 20 feet that it needs here to ring the bell. Does that make sense? So it kind of shows the importance of the vertex of the parabola. It kind of gives you that maximum or minimum. For our purposes, we're going to use maximum. Okay? So should help you a little bit there.